Hey, my name is Prabhjeet Singh. Today I'm going to talk about supply chain inventory management. Introduction to the problem. Stocking inventory in supply chain warehouses in the right quantities is increasing difficult. Mathematical optimization achieves it in a cost-effective manner while managing demands, costs, and other restrictions. Waste reduction with swift and efficient decision streamlines and the entire supply chains. It is seen that modern supply chain face fluctuating demanding limited storage and difficult distribution networks because poor inventory management is the main reason for inefficiency and increases costs. These difficulties can be resolved with computations approaches by considering the demand, supply, and the costs. With the real-time data and consumption methods like linear programming helps any businesses to improve decision making. Problem context real world relevance. Retailers like Walmart and Carrefour face stockouts, overstocking, and distribution delays. Inventory inefficiencies increase operational cost and reduce customer satisfactions. Optimization ensure balanced stock levels and supports effective supply chain decisions. The inventory issues of large retail companies are presented in this slide. Large network manual processes in inventory control are ineffective for Walmart and care for excessive cost and loss of customer service are consequences of stockouts. Inventory surplus and inefficiency distribution optimization demand forecasting and resource allocation allocation provides cost improving operational flow to manage customer satisfaction with available inventory supply. Justification for algorithm solution. Linear programming provides a structure by way to model inventory decision mathematically. Formal mathematical formulation enables accurate optimizations of costs and constraints. LP sport industry practices by improving efficiency and ensuring feasible optimal solutions. This slide illustrates why linear programming in the is the algorithm is important algorithm as it permits the inventory alternatives using a set of variables, constraints, and objective functions for a structured methodological analysis cost. Demand satisfaction and storage limitations are adjusted based on the linear programming mathematical structure provides solution tools for real world supply chains where quantitative decision making in mandatory linear programming markets need to deliver realistic and optimal solution is also the reason why most firms can reduce costs and improve inventory system functions. Literature review. Vicent purposes a MILP model optimizing record quantity, warehouse capacity, and total inventory cost. Roth et al. Introduced a one step ahead optional control by method using linear programming. Both studies demonstrate optimization's role in stabilizing inventory and improving decision accuracy. This slide presents a summary of the two particular research publications. Vicent apply mixed integrated linear programming methodology seeks to achieve optimal order quantity and reduction of supply chain cost while addressing limitations of available warehouse space and also optimally solving the supply chain. In contrast, Roth et al. Introduced one step ahead optimum linear programming control technique which aims to maintaining a desired level of service via stable and responsive inventory control during dynamic shifting situation. Both studies shed on the light usefulness of mathematical optimization in contemporary decision making for supply chain by providing greater control efficiency and order to system oscillations and ultimately improve inventory control. Critical evaluation and literature gap. Vicent 2025 provides robust mathematical modeling in their article but presumes static demand and lacks real-time responsiveness. Roth et al. Provide dynamic control in their article but offer limited contextual validation within the supply chain. Both the study combines linear programming with real-world retailer constraints, but there is presence of significant literature gap. This this slide critique both papers in with Vicent outlines a mathematically rigorous mixed integral linear programming formulation that presumes an unchanging forecastable demand, but it is unsuitable for application in retail. On the other hand, suggest control based on dynamic linear programming, but their model lacks validation in real world supply chain. This shows that the line literature on the subject is not exclusive of the combination of linear programming with the operational constraints of the particular class of retailer. This gap calls for a linear programming based model of inventory optimization in the retail supply chain. Algorithm flowchart. This slide presents the flowchart in which the optimization algorithm is discussed. First of all, it shows in the first stage of the current inventory levels and estimates future needs has been collected based on the that associated cost in calculated. Secondly, the decision variables and the objective function are analyzed and defined properly so that the required constraint determined using that which help in invalidation the model feasibility. So when the linear programming solver in executive, the system determines the optional order quantities and the estimated cost if the constraint allow the solution that are the feasible. Expected outcomes and benefit. The slide outlined the potential benefit of the cost optimization in warehouse management through linear programming. The model can minimize stock out accuracy and the curb inventory costs by balancing cost demand and the warehouse capacity. More formal rules make it easier to allocate warehouse space more fully. Better relationship achieved through correct gasoline land to better result, which improves accuracy in decision making. Conclusion and recommendation. The purpose of the model is to demonstrate the application of linear programming is solving the problem of optimization inventory. The model has the ability to provide a mathematically and optionally efficiency solution to the supply chain problem driven by the presence of decision variable constraints and the goals of optimization. A solid Python model should be developed to answer optimization problem and the complexity analysis as well as parameter sensitivity analysis should be performed. And this is also explained the pseudocode. Thank you very much.